Alright, welcome back. Now in this particular video, we're going to talk about what is called hypothesis testing. Okay, we're going to talk about what is called the hypothesis testing, and this is quite an interesting topic. And we're going to break it down for you to really understand what hypothesis testing is and how you can actually implement this, because we actually have a whole project on this hypothesis testing that we will see when we get to the lab session. We're actually going to see hypothesis testing. We're going to actually do this from scratch in the lab session, and you're going to really get to understand it very well. All right, so let's first start by getting an intuition behind this hypothesis testing. Okay, now if you consider the real life scenarios, right, if you consider the various real life scenarios that we have, we actually make an assumption, then we try to justify our assumption, right? We first make an assumption, right, then we find reasons to justify our assumption, right? So that's what hypothesis testing is about. I mean, we find a hypothesis that is just an assumption that we form, and then the process of justifying this assumption is what we refer to as hypothesis testing, right? So we use some statistical methods to test this assumption to either prove our assumption to be true or to be false. Okay, so we first form an assumption called hypothesis. Then we use statistical concepts to actually prove these assumptions to be true or false, and that is the process is what we refer to as the hypothesis testing, right? We're going to see the various hypothesis testing in our upcoming tutorials and our upcoming lab sessions. Okay, now let's take just one real life situation over here. We all like taking beverages like Coke, right? And if you take a Coke bottle, right, if you take the Coke bottle that Coca-Cola provides, right, if we take the Coke bottle that Coca-Cola provides, normally you will see that they've written 600 ml, right? They've written 600 ml, but we actually don't really know if the bottle they are saying is 600 ml is actually 600 ml, right? The content in the bottle is actually up to 600 ml. We really don't know. We just believe that once they've written it that is 600 ml, then it's true. It could be 600 ml content inside, right? It's true that the content inside is actually 600 ml, but we don't really know if it is 600 ml or not, right? So one can argue that the content in this bottle, in this 600 ml bottle, that Coca-Cola proclaims that they have 600 ml bottle which contains 600 ml Coke, we can actually argue that the content in there is not 600 ml, so it could be less than 600 ml, right? It could be less than 600 ml, or it could be greater than 600 ml, right? We can actually argue that, right, that the content is not actually 600 ml as they claim to be, right? We can actually argue that. Now if you have such proclamation, we can form a hypothesis. So in the first case, the assumption is that the content is having 600 ml. That's the assumption, that's the hypothesis that we have. Okay, that's the hypothesis that we have. Now we can test this hypothesis and see if it is true or not. So the process of testing to prove this assumption is what we refer to as hypothesis testing. Okay, so I hope you have a basic understanding of what hypothesis testing is. So now we have what is called the status quo, right? That is something that is already believed, right? We have something that is called the status quo that is already believed. Now we want to prove that this status quo or this belief or this assumption that Coca-Cola is claiming is not true. Okay, we want to prove that it's not true. That's when we test this assumption to see how true is it, right? We test this assumption to see how true is it. Now let's see how we're going to test this in the next slide. All right, so as I said, we have a status quo, right? We have a status quo that the 600 Coke bottle actually contains 600 ml of Coke. That's the status quo that we have. That's the belief that we all have that is true. Okay, so that becomes the null hypothesis. That becomes what is referred to as the null hypothesis. That what we already believe in is what we refer to as the null hypothesis. Now we're going to set another hypothesis. That's the alternative hypothesis to challenge this status quo, right? That's no, what the Coca-Cola company is claiming that the Coke bottle is containing 600 ml Coke. It's not true, right? It does not contain 600 Coke, though they've written it on the bottle, right? They've written it on the bottle that this bottle actually contains they've written 600 ml there, that the bottle contains 600 Coke inside, right? We can challenge this, that the content is not actually containing that 600 ml. We can do that. Okay, so that becomes an alternative hypothesis, right? That becomes a challenge to the original belief that people have, right? It becomes a challenge to the original belief that people have. So that becomes a challenge to the status quo. Okay, so that becomes the alternative hypothesis that we have. So this is the null hypothesis. It's null because, I mean, there's nothing in there to actually fight for, but we can actually challenge that, because people are not actually challenging that. That's now it's a general belief that we have, right? It's a general belief that we have, but now we want to actually put something against this general belief, right? We want to nullify this belief that they have. Okay, so that's when we set a challenge to this status quo that people have. Okay, so that's when we will start having these two null hypothesis and then alternative hypothesis. Okay, so I hope this is clear for you. Now what we're going to actually do is to set what is called the null hypothesis and then the alternative hypothesis in a test form, so that, I mean, in a test statistic form, so that we can actually test this hypothesis, right? We can challenge this status quo in a more grounded form, right? So what normally we do is that we use this symbol, right? This is which represents the null hypothesis, right? So we see that the population mean, that is what the general population believe, that the 600 Coke bottle contains 600 ml, right? We actually going to challenge that and say that no, it doesn't actually contain that. Okay, then we set an alternative hypothesis over here, which is going to be H1 or HA, whatever you want to do. So now the population is going to challenge this status quo. Okay, the population is going to challenge this status quo and say that whatever content that you have is not up to 600 ml, right? So the content you have in your 600 ml bottle is not actually up to that content that you claim. Okay, so you set this, so this becomes the statistics that you're going to actually test with regards to your hypothesis testing. Okay, so this is something that you're going to actually test now. Okay, now you have these two to actually test. You have what the general population believe in, right, and what you want them to believe now, right? What you want them to believe now. You want to challenge what is already existing over there. Okay, now having gotten an intuition behind that, right? Now if we get to break this thing down further, right, we see that the content of the bottle, right? So we have the bottle, right? Coca-Cola is actually claiming that this Coke bottle is containing 600 ml. Now what we are saying is that the bottle does not, right? The bottle does not, right? Does not contain 600 ml. Okay, so if it does not contain 600 ml, then it can either contain more Coke, right? It can either contain more Coke or it can contain less Coke. Okay, it can either contain more Coke or it can contain less Coke. Now in that case, right, in that case we are actually testing either side of the situation. We are either testing, I mean, whether the content is either high or the content is either low, right, or less than what they claim. So in that case we have we have what is called the two-tailed test. We are testing either side of the tail. The tail is nothing but the normal distribution tail, right? So remember that we talked about this. Let me draw it well for you to understand. We talked about the normal distribution, right? So we have the tail here, okay? So we are testing either side of the tail. So the content can be either more, right? It can be either more or it can be less. Okay, so that's what we are actually testing. That's why you see that we have two-tailed test, right? It's either more or it's either less. So it's either the content is equal to 600 or it's not equal to 600. So in that case, we're going to check if it is less or it is more. All right. However, we can also argue in a different way that no, the content is actually more than 600 ml. So our argument has changed now. Now we are not saying that the content is not equal to 600 ml, right? But we are saying that the content is more, that is greater than 600 ml. Now our argument has actually changed. In that case, we are testing only one side. Now we are no more interested in whether it is less or not. We are only interested in the fact that it is high, right? And we can also argue that the content is less than 600 ml. So if we do that, then we are no more interested in whether the content is more or not. Our interest is that the content is actually less. So in that case, it becomes one tail test. So either you argue for either high or you argue for either low content. That becomes one tail test. Okay. So the next slide will actually make you get it, which is quite a good drawing over here. Okay. Now you can actually see that if we use the content like so, let's say this beta function is just our cook, right? So we can say that this is equal to 600 ml, right? So our beta here is equal to 600 ml, right? Or not equal to 600 ml. Okay, so if it's just not, it's either we are giving for whether it is greater than or it is less than 600 ml. So if it is greater than 600 ml, we talking about this side. If it's less than 600 ml, we are talking about this side, right? We're talking about this side. So we can put our 600 ml here, and then we can argue whether it is the content is either greater than 600 ml or less than 600 ml. Right. We can also argue that the content is greater than 600 ml. In that case, we are only interested in this part, or argue that the content is less than 600 ml. In that case, we are interested in only this part. Okay. So this is the one tail and then the two tail test. All right. So I hope this one is clear for you. Now the next one that we're going to talk about is some of the notes that you need to take when with regards to hypothesis testing. Okay. Now, what you need to know is that we already have our null hypothesis, right? We already have our null hypothesis. That's the status quo, what people already believe in, right? That becomes our status quo, right? That's what people already believe in. So we have null hypothesis, right? That's the status quo. What you're going to do is that you want to find a reason to either reject this null hypothesis. So if Coca-Cola is claiming that they have 600 ml content in their 600 ml bottle, then we want to find a reason to reject this, right? This is already being accepted by the general public, but we want to find a reason to reject that. So your result is that you either reject this or you fail to reject it, right? You are not going to accept it because it's already accepted, right? So we don't say that we have accepted the null hypothesis. It's already accepted by the public that the 600 bottle is containing 600 ml of Coke. So that one is already being accepted by the general public. So you are not going to prove that you are not going to accept it again. It's already being accepted. What we can do is to either reject it or fail to reject it. Okay, we assume that the null hypothesis is true from the beginning. Okay, that's what we already assume. So later on, what we are going to do is that we are either going to reject or we are going to fail to reject, right? And when we reject the null hypothesis, then we can actually conclude that the alternative hypothesis is now being supported, right? So if we are able to reject the fact that they say the content is 600 ml, we are able to reject that and then prove that the content is not containing 600 ml, then we are actually our alternative hypothesis, which is saying that the content is not containing 600 ml, is actually being approved. Okay, now if we fail to reject the null hypothesis, right? If we fail to reject the null hypothesis, it does not mean that we have proven the null hypothesis to be true, right? Thus, we fail to prove that the 600 ml bottle contains 600 content of Coke, 600 ml content of Coke. If we fail to prove that, right, that what the company is claiming is not true, if we fail to prove that what the company is claiming is not true, right, it does not mean that we have proven it to be true, right? It does not mean that we have proven it to be true either. What it means that we don't actually have enough evidence to reject it. Okay, it doesn't mean that we have proved it to be true, but what it means that we don't actually have enough evidence to actually reject it. Okay, so if we do all our hypothesis testing and then we realize that we don't have enough evidence to reject this claim that the company is claiming, doesn't mean that we have proven them to be true. It means that we didn't get enough evidence to prove them wrong. Okay, it means that we didn't have enough evidence to prove them wrong, but that doesn't mean that we have proved them to be right. Right, our purpose here is to prove them to be wrong, but if we are not able to prove them to be wrong, it means that we don't have enough evidence to prove them wrong, but we are not proving them to be right either. Okay, so that's basically the what you need to take note of when we are dealing with the hypothesis testing over here. Okay, now there's also these two concepts that you need to actually get to note before we get to doing projects. We're actually going to meet what is called type 1 and type 2 error. We're going to see it quite often, right? So let's get to understand this and what it means. Now let's say you form your hypothesis, right? You form your hypothesis, so you have your null hypothesis, that's the H0, then you have your alternative hypothesis, that's H1, right? So earlier on we are saying that the status quo over there is that the bottle is having 600 ml, okay, content, and then you argue that the bottle is not having 600 ml content. Okay, now if you do this hypothesis testing, right, and then you are not able to get any concrete evidence against this company to actually disprove their fact that they say that the 600 ml bottle is containing 600 ml Coke. If you are not able to have enough evidence to prove them wrong, yet you go ahead and then reject this null hypothesis, that's what they are claiming, you go ahead and reject this, then you are making a type 1 error. You're making a type 1 error. That is, you definitely know that the content over there, right, you did not have enough evidence to prove them wrong, but you are still going around and saying that the company is actually deceiving people and their content is not up to 600 ml. Meanwhile, you did not get any evidence against them. In that case, you are making a type 1 error. Okay, you are making a type 1 error. However, if you do the hypothesis testing and you get enough evidence against them, right, and then you realize that some of the bottles you tested them, the content is maybe around 500 ml or maybe something like 550 ml, right? So this one is not up to 600 ml, but since maybe the companies saw you, at the backside, on they gave you maybe something, right? They put something in your pocket and then you begin to keep quiet, right? Though you found the evidence against them, but since the company bribed you, right? They actually put something in your pocket, so you begin to keep quiet regardless of the evidence that you have. Then in that case, you are making a type 2 error. All right, you're accepting the null hypothesis. That's, you're accepting the fact that the content is 600 ml. Meanwhile, you really know that the content is not. You found out that it's not, which is kind of a corruption that you are doing. That in that case, you're making a type 2 error. Okay, in that case, you're doing a type 2 error. So that is type 1, type 2. So anywhere you meet it, you can just relate it with it in this simple analogy. Okay, now the next thing that you can see is a visual representation over here. Now let's get to see this. At the normal circumstance, if a man visited the hospital, right, we expect, in our normal society, it's a woman who can get pregnant, right? It's a woman who can get pregnant, but it's quite rare, or it's quite uncommon to see a man to be pregnant, right? However, if a man goes to the hospital and the doctor go to the hospital for checkup, and then the doctor comes out with the result and say that the man is actually pregnant, then this is actually a false positive, or a type 1 error, right? That's when the doctor is not having any evidence against the man that the man is pregnant, yet the doctor is saying that the man is pregnant, right? Pregnancy is a positive thing, but saying a man is pregnant is a false positive. Okay, pregnancy is actually a positive thing, but if you say a man is pregnant, that is a false positive. Okay, or alternatively, you can call it a type 1 error. All right, now if a woman is pregnant and the woman goes to the hospital, right, we expect the checkup to come up that the woman is pregnant, because we all can see the woman is pregnant. Okay, so if a woman goes to the hospital for checkup for pregnancy test, we expect that the results will come as pregnant, right, as the woman is pregnant. However, if the results comes and the doctor is saying that, oh, you are not pregnant, whilst the doctor really knows that the woman is pregnant, then we are making a type 2 error, right? We are making a false negative, right? We're making a false negative, right? Saying that you are not pregnant is actually a negative thing, but in this case it's a false negative. That is a false negative claim that the doctor is actually making, right? The woman is pregnant, but the doctor is actually saying that the woman is not pregnant. So saying that you are not pregnant itself is a negative thing, but in this case is a false negative, right? What we really want is a true positive and then a true negative, right? If the woman is not pregnant, we really want to see the woman not pregnant, and if the man is not pregnant, we really want to see the man not pregnant. Okay, so we want a correct conclusion, right? That is a true positive and then a true negative, not a situation where the man is not pregnant but the doctor will say the man is pregnant, or the woman is pregnant, the doctor will say the woman is not pregnant. Okay, you're going to see this concept as we talk about confusion matrix in our project. Almost all of our projects will be doing confusion matrix, and you're going to see this concept, right? So this is just a screenshot that I took from one of the projects that you'll be doing. Okay, so whether the result is yes or no, right, we can predict yes or no, and you can see that some of the no's we're able to predict right, but some of the no's we're predicting yes. So some of the yes we're predicting no, right? So this is our prediction, this part is our prediction, this is the original one, right? This is our original one, this is our prediction. So although the correct prediction was say yes, right, but we predicted that to be no, we predicted 33 of them to be no, and then whilst the no is here, right, we're able to predict 1,346 of the no's correctly as no, right? However, some of the yes that were supposed to be predicted as yes, right, we're supposed to be predicting them as yes, we predicted them as no. Okay, in the same way, some of the no's that we were supposed to predict them as no, we predicted them as yes. Okay, we predicted them as yes, and some of the yes that we were supposed to be predicted as yes, we are correctly predicting them as yes. Okay, we're going to actually see more of this. Right, let me just even show you some of them over here. Right, let me show you. So you can see this project over here. We have a confusion matrix here. So you can see the name itself is a confusion matrix. So it's actually confused, right? So that's why you can see the man is not pregnant, but the hospital, the doctor is saying the man is pregnant. That's a confusion kind of a result that is coming. The interpretation itself, if you have to take care, because it's actually confusing. Now in this case, you can see that this is the true label, this is the original label, this is the one that we predicted, right? This is our prediction. Now there are some patients who are diabetic, there are some who are not diabetic. So originally there are some patients who are diabetic, and some patients who are not diabetic, and then there are some who are diabetic. So we want to predict those who are diabetic as diabetic and those who are not diabetic as not diabetic. Okay, so if you pick the original people who are diabetic, right, we're able to predict 108 of them as not diabetic, right? Those who are not diabetic, we're able to correctly predict them as non-diabetic, right? However, you can see that 11 of them who are non-diabetic, we're predicting them as diabetic, right? We're predicting 11 of these as diabetic. And if you can see over here, 26 of those who are diabetic, we're predicting them as not diabetic, which is very serious, right? We're predicting them as not diabetic. However, we can see that 36 of them who are diabetic, we're able to predict them correctly as diabetic. Okay, so this is what we're going to use that type 1 error, then type 2 error, and the confusion matrix to actually do. Okay, so I hope you have an intuition what this actually means. We're going to see more of these over and over again, which will make it quite simpler for you to understand. So there's no need to actually worry about that. Okay, now there are some process that you need to follow. There are some process that you need to follow when we talk about hypothesis testing, right? So let's go through this one by one. I put this for you so that it will summarize everything for you. Now, if you want to do hypothesis testing, right, what you can do is that first you have to determine your null hypothesis. Okay, let me get rid of that. First, what you need to consider. Okay, what you need to consider is first you have to determine your null hypothesis, right, and your alternative hypothesis. That's what you need to actually consider first, your null hypothesis and then your alternative hypothesis, and then you collect and summarize your data, right, into test statistics, right. What I mean by that is when you do your H0, right, in this case we say that the general population believe that the bottle is 600 ml, right, and then we set an alternative saying that we want to change that perception as so that the general population will start to believe that the 600 bottle is not up to 600 ml, right, the content in there is not up to 600 ml. So this is the test statistic that you need to set, right. You need to set that. So after you first do your null and then the alternative hypothesis, then you do this one, and then after that you test this using what is called a p-value and then the level of significance. We're going to see explanation of this in the next slide, right. So let's see what p-value is and what level of significance is. All right, now if we take the p-value, right, the p-value is nothing but it's actually used in hypothesis testing to help you support or reject the null hypothesis, right. So that's what we're going to use the p-value for, to either support or reject the null hypothesis. So in this case we have our null hypothesis to be the fact that the bottle, right, what the general public believe in, that the bottle of the Coke, right, is actually 600 ml. We want to use this p-value to either reject this or fail to reject it. Okay, to either reject this or fail to reject it. Okay, so that's what we use the p-value for. And if we calculate the p-value, we're going to see the calculation of p-value when we go to the lab session, or you're going to see an example of that. Now, if you calculate the p-value, right, what you need to expect is that we want the p-value to be as small as possible, right. You want your p-value to be as small as possible. You want it to be as small as possible. So if you have a p-value of say 0.025, it means that you have, let me push this here. Okay, if you have a p-value of say 0.025, it means that if you convert it to percentage, it means that you have 2.5%, right, only by 2.54% that your results might have been happened by chance, right. You want your results to actually be happened accurately as you are testing them, not just by chance but by concrete evidence. Okay, by concrete evidence, maybe you'll pick around say 100 or 1,000 bottles of the Coke, of the 600 ml Coke, right. You'll pick 1,000 of them to actually take them to the lab to check the content of them, right. So the result that will come, maybe out of the 1,000 you just choose 10 of them and then you test it. Maybe the 10 of them were the ones that were not up to 600, so that is it just happened by chance. Or maybe the 1,000 that you chose out of the numerous Coca-Cola products that you have, numerous Coke that the Coca-Cola company has produced, right. You just choose 1,000 of them, but these thousands could be happened by chance, and then by chance you have some bottles in there which are not up to 600. So you don't actually want your results to be by chance. You want a real concrete evidence. Okay, so if you have a p-value which is small, it means that you only have a very small number of you only have a very small chance that the results that will come out will be just a random and not based on concrete evidence, right. However, if you have a large p-value, it means that your result is actually, for instance, if you have a p-value of 0.9, that is at 90% of the time, or you have a 90% probability that the experiment that you did is actually happened by chance. The result is actually by chance, right, which you want to prevent. So you want your p-value to be as small as possible, right. But how small your p-value can be, right, this is another thing that you need to check. That's why you need to set something that you can actually compare your result with. right? That's when the concept of significance level actually comes in. So you need to have something that you can compare the p-value with. Okay, so if you want to say, let's actually see this significance level and then compare the two, significance level and the p-value. Okay, so now if we want to talk about the confidence level or the significance level, then what we can actually talk about is the alpha value or the alpha level, right? And this is controlled by you the researcher, right? You just choose the confidence level that you want. So let's take, for instance, you want to be 98% confident that the research that you're doing is actually concrete and it's coming from real experiment and not just by chance. Okay, so you want to be 98% confident. So in that case, you choose your alpha level to be, say, 2%, which is going to be 0.02, right? You choose it to be 2%. Or I mean, generally you'll be seeing 5%, which is, I mean, something that people have tested over and over again and found it to be quite wealthy to use. So you'll be seeing by default some of the statistical tools that you'll be using is actually using 0.05, that is 5% confidence level, right? So if you choose your alpha level to be, say, 0.05, then you want to be at 95%, right? At 95% of the time, you want your results to be right? You want to be confident at 95% of the time, all right, that your result is actually right. So if you now calculate the p-value, right? If you calculate your p-value and it is smaller than this, right, then you're going to reject the null hypothesis. Okay, if you calculate the p-value and it is smaller than this confidence level that you have taken, right, then you're going to reject the null hypothesis, and that means that you have a strong evidence, right? You have a strong evidence against the null hypothesis. Okay, now the small p means that now if you have taken, say, if you have calculated the p-value and you get, say, 0.02, which is smaller than 0.05, it means that you are at 98% sure that the null hypothesis is not true. Okay, you are at 98% sure that the null hypothesis is not true. All right, now you set this one to actually make sure that your results is not happening by chance, and then you use this one, the p-value, right? You use the p-value to actually be confident that the evidence that you have is right. Okay, so if your p-value is actually less than this alpha level, then you can actually know that you have a strong evidence against this null hypothesis and you can now reject it. Okay, you can now reject it. Now we want evidence against it. What we are doing is that we want evidence against the fact that the 600 ml bottle is not up to 600 ml Coke, right? We actually want evidence against them. So if you are very confident, right, if we have a very confident that our claim that is the alternative hypothesis is true, then we're going to reject the null hypothesis. Okay, if you have a large p-value, then it means that the alternative hypothesis is weak. We don't actually have enough evidence against what the company is claiming, and we're going to refuse to reject the null hypothesis. Okay, now we have a general analogy here which you can use always. Now if you calculate the p and it's small, then the null must go. That is, you have to reject the null hypothesis. So we generally say that if p is small, null must go. Okay, if p is small, null must go. So that's the general analogy that you can take. So this is just the summary of everything that we've done here. You set your alpha level. Normally you just choose maybe 0.05. If it is a medical research that you're doing, then you can choose higher than that, which it could be, say, 0.01, or that is 1%. That in that case you want to be 99% confident, right? Because in medical situations it's quite critical. You have to be careful that you don't kill people. Okay, so you have to be very, very confident. So if you can set it to say 0.01 or 0.02, okay, and in that case if you calculate this and it's maybe 0.0001, then this is less than this, then you can reject it. Otherwise, if it is greater than it, maybe 0.03, right, then you can reject you fail to reject your null hypothesis. All right, so generally, just summary of everything that we've done so far, right? With summary of everything that we've done so far, you set your alpha level, you find your p. If p is small, null must go. As simple as that. Okay, you set your alpha level, you find your p. If p is small, null must go. Just as simple as that. All right, so this is the confidence level. I mean, this is just the same thing that I've told you earlier on, right? So you just set your confidence level, that is, you want to be 95% sure that your result is actually accurate, okay, your result is actually true. And if you check your p and your p is less than your alpha level, right, then the null must go, that is, you have to reject the null hypothesis. If the p is actually greater than your alpha, then you failed, right, you failed, that is, not reject the null hypothesis. Okay, this as simple as that. All right, so this concludes our class. This concludes our statistics class, and in the next video we're actually going to go to the lab session, and we're going to see a practical implementation of the concept that we've learned so far. We're going to actually put this into practice. We're going to see a hands-on demonstration of everything, right? So we head on to the lab session and we do that, and as we progress we're going to see more of these concepts over here. So some of them might not be clear, I mean just by now, but as we progress in the course you're actually going to encounter them over and over again, which will make things quite clear. We're going to go to the lab session, demonstrate it for you to actually understand these concepts. Okay, I have some extra resource over here, which are some additional stuff that I've put over here. So I'll actually upload this slide for you so that you can actually get to understand some examples in there. Okay, so thank you, and have a nice day. See you in the lab session.